Hello everybody and welcome to Methodical Math. We're going to talk about integration by parts today. Why does integration by parts even exist? Well, the integral of a product is not a product of integrals. And what do I mean by this? This just simply means if I have an integral of f of x dx times the integral of gx dx, this cannot equal the integral of f of x gx dx. We cannot split it like this. So we have integration by parts. We have a quick formula, uv minus v du, and we will follow this equation all the way through on every problem. I will teach you how to decipher what's going to be u and what's going to be v. Let's just jump right into an example. Example 1. We want to take the antiderivative of x cosine 5x dx. Step number 1. You're going to create a u, a du, a dv, and a v. All right. Step 1 is to decide what is our u going to be. There are tricks that I will explain in other videos of how to choose the proper u and the proper dv, because you can choose the wrong thing. But in this case, we're just going to go ahead with the first thing that appears, which is our x. U to du is a derivative, so the derivative of x gives us dx. He's out. Now dv is whatever is left over. Cosine 5x dx. All right, just like u to du is the derivative, we're going to go ahead and take the antiderivative of cosine 5x. This will give us sine of 5x all over 5. Now we just have to plug into our equation given. So our u is x. We're going to multiply that by our v, which is a sine of 5x all over 5. Subtract off our integral. We have our v again, so we have sine of 5x all over 5, and our du, in this case, is dx. So I'm simply just going through and plugging in my values for each of these that appear. All right, so it depends on how you like to see v here. Some people like to write it as a 1/5 of the sine of 5x. This becomes important because whenever you have a constant, and a constant is just any number such as this, they are special and they also are known as a. They can move back and forth between an integral without changing. However, this helps tremendously because taking antiderivative without a fraction is much easier. So let's go ahead and just simplify this problem up. So we have x sine of 5x all over 5. Subtract off our integral. I'm going to pull out, so let me take one step back. I'm going to pull out our 1/5 here. So I have a minus, pull out that 1/5. Take the integral, what is left over? We have sine of 5x dx. Now compare the difference. We have a sine of 5x over 5 dx, or we just have the antiderivative of sine 5x. This one is going to be a lot easier. So let's go ahead and simplify. We have x sine of 5x all over 5. Subtract our 1/5. We're going to multiply that 1/5 by the antiderivative of sine of 5x, which is going to give us a negative cosine 5x over 5 plus c. We are almost there. One last step is to simplify one more time. We have x sine of 5x all over 5. We have a negative to a negative, which gives us a positive cosine 5x for the numerator. Over our 5 times the 5 will give us a 25 plus c. All right, so let's go on to another example here. We are going to integrate x e to the 2x dx. right, let's go ahead and write up our cheat sheet up top. uv minus the integral of v du. All right, step number 1. We have a u, du, dv, and a v. Once again, I'm going to choose x because it's the simplest to take the derivative of. So I'll plug in x for u. The derivative of x gives me dx. And he's out. What am I left with? I have an e to the 2x dx. Go ahead and put this in a bracket so we know where we're at. Now the antiderivative of e to the 2x will give us 1/2 e to the 2x. Perfect. Let's go ahead and plug into that equation. We have x, which is u, times v, which is 1/2 e to the 2x. Subtract off our integral. V again, 1/2 e to the 2x. Du is dx. Perfect. Now remember what we said about those constants. Let's go ahead and pull him right on out before we go ahead and take the antiderivative one more time. So I have x e to the 2x all over 2. Subtract off, pull out the 1/2. We are left with e to the 2x dx. Luckily, we've already taken this right up here. So we can just copy that or just take it one more time. X e to the 2x all over 2. Subtract off our 1/2. Multiply by the antiderivative here, which was 1/2 e to the 2x. Add on our c. Last step is just to simplify, so we're just going to multiply in that negative 1/2. X e to the 2x all over 2. We have a negative e to the 2x all over 4 plus c. Perfect, and that is our final answer for that one. All right, I'm going to give you one trick at this stage called lie it. And this can help you if you're having troubles deciding what u and what dv to choose in your problem. The L stands for logs, I is inverse trig problems, algebraic, regular trig, and exponentials. So this will help when deciphering. So if you recall back to our x cosine of 5x equation, I'm going to literally go through, so I have my u set up and my du, along with my dv and my v. I'm going to decide what comes first on this. So do I have any logarithms? I do not. I do not have any inverse trigs. I do have an algebra problem here, and that involves x. So that's how I know this is going to be x. dv is whatever is left over. And then another key, how do I know I have integration by parts? The one key to knowing you have an integration by parts problem is x shows up twice in the same problem. So as you recall from the last problem, we had x e to the 2x dx. I have an x right here, and I have an x right here. This tells me I have integration by parts. Let's go ahead and do one final problem. I like to call this problem an onion problem because it has so many layers. We have integration by parts twice in this equation. So let's look at the integral of t squared sine of beta t dt. All right, do not let the beta throw you off in this case. The beta is just like any other number, and we're going to treat it as a constant. So let's go ahead and set up our problem. U and du, dv, and v. Now if you want to go ahead and pause the video at this point and see if you get the same answer as me, we'll just go right into it. I'm going to do my t squared, and the derivative of t squared gives me 2t dt. He is out. Whatever I'm left with, which in this case is a sine beta t dt. Perfect. Now dv to v is the antiderivative. So the antiderivative of sine is a negative cosine beta t all over beta. All right, do you happen to remember our equation? Let's go ahead and plug it in without looking. So we have uv, which is t squared, times a negative cosine beta t all over beta. Subtract off our integral of v du. V again is a negative cosine beta t all over beta. And then du is 2t dt. All right, so we are not quite done. We are about halfway at this point. However, what I like to do is pull out my constants. In this case, it's a negative 1 over beta and a 2. Because these are products, they can come out together. So let's just go ahead and rewrite this before we move on. I have a negative t squared cosine beta t all over beta. I have a negative of a negative. We're going to go ahead and pull out the negative 1 over beta times 2, so 2 over beta. We are left with the integral of cosine beta t times a t dt. All right, it's really easy to get lost in these problems. Keep your workstation clean, and as you can tell, I like using a lot of arrows, but it's going to be key when you're taking parts 2. How do I know I am not done here? Well, I have a t here and a t here. So we have integration by parts, part 2. Let's go ahead and do that right under where we're at. We will keep this section, but this section will be our parts 2 plugin. So let's go ahead and do parts 2. Parts 2. All right, so we have a u, a du again, a dv, and a v again. All right, now if you want to rewrite just the portion you're working with, we can go ahead and do that. Makes it a little easier to see. So this is just this part 2. All right, well, I have a t here. He's going to be the easiest to take the derivative of. So t turns to dt. He's out. Whatever's left over, which is a cosine beta t dt. We're going to go backwards again. The antiderivative of cosine would give me a sine of beta t all over beta. And excuse me, that one, yes, that's correct, over beta. Okay, let's go ahead and plug into our equation, which, do you remember what it was? uv minus v du. Okay, so we have u, which is t, times v, which is sine of beta t all over beta. Subtract off our integral again. We have v again, so sine of beta t all over beta. Du is dt. Whew, all right. Let's go ahead and clean this portion up. We have t sine beta t all over beta. I'm going to pull out this 1 over beta once again. He is our constant. And then we're left with the integral of sine beta t dt. We know the antiderivative here of this guy is negative cosine beta t all over beta. So that is the antiderivative. So what I'm left with, we're going to go ahead and rewrite this portion right here, down here. We have a negative t, so you're combining parts essentially. So this was our part 1, and this is our part 2, which is all of this work. All of this work is our part 2. So let's go ahead and rewrite our part 1. Part 1 was t squared cosine of beta t all over beta. We have a plus 2 over beta. Perfect. Now we're going to multiply in our parts 2. So let's just go ahead and add this straight in. So we have a t sine beta t all over beta. We have a minus, but remember this got switched with cosine, negative cosine, so I'm going to go ahead and multiply this in at this stage. So I have a negative 1 over beta times a negative cosine of cosine beta t over beta. So that gives me a positive cosine beta t all over beta squared. All right, and I promise we are almost done. The key to this problem, though, once again, is remembering parts 2. This is what we got for part 2. Plug it right on in. Part 1 goes right up front. All right, last stage, we have a negative t cosine beta t all over beta plus, let's go ahead and multiply in our 2 over beta. So we have a 2t sine beta t all over beta squared plus a 2 cosine beta t all over beta cubed plus c. All right, this is our final result. If you have any questions, please leave a comment in the description down below, and I'll do my best to answer all of them. I will have more videos out shortly showing more examples of how to do integration by parts. Until then.